Hello all, welcome to my channel. I'm back with another video. In this video, we will be going through some of the concepts of Databricks Lakeflow. So the reason I'm making this video is I have seen people getting confused between the newer offerings that has come up with Databricks, and they treat them individually, which doesn't go well with the design. Uh, so let's get started and see what is there in the Lakeflow. So Lakeflow is an unified solution that offers that caters to the different aspects of a end-to-end data pipeline or data product, I will say. And in at a high level, Lakeflow is an ecosystem which has different components for different layers. So, for example, uh, a data pipeline consists of ingestion. The ingestion can be of a batch mode or in stream mode. So, for ingestion, we have Lakeflow Connect, and for streaming cases, let's say something similar to how Kafka was there in on open source systems. So Databricks offers something similar, which is called Zerobus for streaming ingestion. For transformation, we have Lakeflow pipelines, which convert or transform the data from one stage to another stage or one layer to another layer. And to orchestrate these things, we have Lakeflow jobs, which can be thought of something similar to how Airflow offers orchestration. Lakeflow job is not equivalent. We should not be comparing Lakeflow jobs with Airflow, but it has certain capabilities which Airflow has. And then at the end, we have Lakeflow Designer, which is nothing but a no-code solution where using a drag and drop tools, we can build an end-to-end pipeline or data movement strategy. So let's go deeper into each of the components to understand how it is there, why it was built for certain use cases. So first thing is Lakeflow Connect. So Lakeflow Connect is a suite of connectors which are built by Databricks team, which are highly performant. They are optimized for speed. They support incremental read and writes. So they made those connectors. For example, let's say we want to get data from Salesforce. We want to get data from Workday, Google Analytics, or ServiceNow. How do we if we have to build the connectors ourselves, the iterations will be hard. We will have to maintain a lot of things in there, like how we retry, I mean, best practices to make an connector, and we have to write code which is optimized that can be checkpointed and stuff like that. So what Databricks is offering as part of Lakeflow Connect is they are offering these connectors out of the box, which we just can simply configure, and it will be able to ingest the data. So they are built in a way that it supports uh, failures. Even it can support automatic recovery from failures. It can integrate with Unity catalog, and the whole pipeline that we see of Lakeflow Connect is nothing but abstraction on top of Lakeflow's declarative pipelines, which we will see down the line in this video itself. And it's so in general, it provides the Lakeflow Connect provides a comprehensive monitoring, event logs, cluster logs, pipeline health metrics, and data quality metrics. So it provides all those metrics as well. And at the same time, Connect also supports SCD type 2, makes slowly changing dimension type 2 tracking, so that we can maintain the history over time as well. And then we have, so this is I will say is an I will say it's a one level deeper. So for the example, if this was the ecosystem level depiction of Databricks as Lakeflow, this is an uh, one step down if we go and see. So Lakeflow Connect is nothing but it is built on top of Lakeflow pipeline, which is nothing but a Delta Live table, which works on Spark streaming and Spark batch. Then we have Lakeflow jobs, which orchestrates these things. And then we have Lakeflow designer, which we can use to build this ecosystem using a no-code tool. So that is what this diagram is all about. So coming back to the components that we have, Zerobus, as I was mentioning. So Databricks didn't have any event bus kind of a solution till now. So if you have to implement something like that, you will rely on some external tool. For example, you will have to rely on Kafka, you will have to rely on RabbitMQ or Buff or other streaming solutions that were there to consume data from and then bring it to the database system. But now Zerobus, with Ekflow Zerobus, we have a direct write API available that we can use to push high volume of event data directly to our lakehouse with near real-time latency. So near real-time, when we say it is not actual real-time, it's like it can be at second or sub-second level. So earlier what we used to use, I mean, what we had use cases of Kafka. Zerobus is trying to fill that gap that, okay, you don't have to rely on an external system to consume those messages. You can use Databricks Zerobus to uh, make the same use cases solve using Zerobus because it gives near real-time latency. I was saying it's a 5 second latency. It is the message size is of 4 MB. Throughput is 100 Mbps, and then we have it supports at least one semantics. The SDKs are already there in Python, so we can use Python to push, publish, and consume from this. And there is no, I mean, as of now, this is a one limitation that is there, that it does not support any transformation as of now. So basically, you can simply just consume it. Means you can simply write it and consume it. There is no transformation. If you want to transform the data, you will have to use this Lakeflow pipeline to do the further transformation that you want. And that brings to our next component, which is Lakeflow pipelines. So Lakeflow pipeline is built on top of declarative pipelines, which has now been given back to open source Spark as well. So why we need a declarative approach? So for example, there are two different ways of solving a problem. One is declarative approach, one is imperative approach. In declarative approach, we simply tell what we want to do. We are not bothered about how it is happening behind the scenes. Like for example, SQL is a declarative language. We don't tell what join strategy or what you want to use. We simply said, okay, we want this data, and then data is returned back. But let's say if we are writing the same code in Python, let's say using PySpark, then we tell, okay, do this, do that, first transform this, transform that. So that becomes kind of a imperative. Or let's say Ansible is an example of a declarative pipeline. Terraform was a declarative pipeline. So that way, this Lakeflow pipeline is trying to bring declarative nature to the data pipelines that is there. And what it is behind the scene is nothing but, as I mentioned, it is running Spark structured streaming or Spark uh, in general for batch cases. And this allows us to build, we declare the pipeline using YAML or certain other configurations, and then the computation happens, or the how part is decided by this pipeline, and it runs by its own. And there are two modes of this. One is an append mode, another one is a CDC mode. So append mode is where you will keep on appending the data, while CDC you might be updating your data as well. Then we have Lakeflow jobs. Lakeflow job is, as I mentioned, it's an orchestration layer. So for example, let's say we have three different components. So let's say we have built a pipeline, uh, let's say Lakeflow pipeline itself, which does transform one set of data. Let's say we are getting data from Workday, we transformed and put it into gold layer. Then we also have one other pipeline, or we have just put till the silver layer because we are dependent on some, let's say, some other source of data. Let's say we are dependent on Workday's data. So we have another pipeline which using Lakeflow Connect and Lakeflow pipeline that we have built that publishes data, that gets the data and publishes it to silver layer. And then we have another pipeline which runs once these two pipelines finishes in the silver layer, then it combines those data and publishes into a gold layer. So to orchestrate these layers, or the synchronization between these three jobs, let's say the job 3, which is for moving data from the silver layer to the gold layer, should be dependent, or it should only start when this the other two jobs of from Workday and Salesforce is complete. That's where this Lakeflow jobs comes into picture. We can create jobs to orchestrate different components, and It supports a wide range of trigger types. Then when we want to trigger a particular job, it also supports branching, resolving the dependency. It also handles retries and everything. So Lakeflow job is we can say it is an Airflow for Databricks in a simple terms. It is not as capable as an Airflow because that's a whole different scenario. But whatever things are needed from a data pipeline perspective is available in data Lakeflow jobs, and it's completely managed as well. And then in the end, we have a component called Lakeflow Designer. So basically, Lakeflow Designer is an AI powered no code pipeline builder that is fully integrated with Databricks ecosystem. So we get a visual canvas. For example, let's say if you just drag and drop an node and then connect it using connectors that are available. So it will allow us to build a whole end-to-end pipeline and everything without us knowing the intricacies of how it is happening. So it creates behind the scene, it will create a declarative pipeline under the hood, and it will run, but we don't have to know declarative pipeline to work on if we are using Lakeflow Designer, because this makes Databricks is doing this to make the entry barrier into data engineering lower, so that people who don't have that much of data engineering skills can still make pipelines using these Lakeflow designers. So it has smart AI systems as well. You can ask questions in natural language. It will provide the full steps as well, and there is no code involved in this. It is all drag and drop, so it makes life easier for us to build pipelines. But only thing is, it is still limited to Databricks. So if you have external integration, it can't do that as of now. In future, it might do. So this was it for this video. We have covered all the Lakeflow components like ingest, stream, transform, orchestration, design. Uh, I hope this was helpful, and if you found it helpful, do share it and support the channel. Thanks. Have a nice day.